second example on page 35. So here we've got 2.5 grams of ammonia gas and is mixed with 6 grams of oxygen gas, and then 2.75 grams of nitrogen monoxide gas is produced. We're given masses for our two reactants. We know it's a limiting reactant question. So if we look at our balanced equation, we're starting out with 2.5 grams of this, 2.50 grams, and 6 grams of that one. Okay? Must be limiting reactant. That's going to be the first step that we need to work out which one is the limiting reactant. We need to find out how many moles of ammonia we have. Remember that we're going to now, because we've got masses, it's the sample mass divided by the mole mass is the formula we need to use. So we've got 2.5 grams of that. We're going to divide it by the molar mass of ammonia. Notice that the coefficient it's not involved at all. That's just for our balancing out our reaction, which gives us 17 grams. Ooh. Oh, no, we don't want that. Sorry. We just want to know the number of moles.
The question uses 3.5 grams, not 2.5 grams.
That was something we were looking at. Oh, I was looking at with Jennifer. Yes, I think the easy way to fix it is to just change that to 3.5. Just change that in your books. I'll just check that that's giving us the right. Yes. 5. That's actually 5 there. All right. Then we need to do the same for the oxygen. Now, if we look at the coefficients, so if I put my oxygen on top of my ammonia, and then look at the coefficients, that would be 5 on 4. And I put my actual moles, it's 0.1875 divided by 0.2055. My answer equals, that gives me 0.9125, whereas 5 on 4, 5 divided by 4 is going to be what, 1.25? So because 0.9125 is less than 1.25, oxygen must be the limiting reactant. Is that everyone happy with that thinking process? Yeah, okay, good. Right, so again, when I was looking at some people in that limiting reactant question in the assignment, worked out the first part correctly and then used the wrong value, used the one that was in excess. So you do need to make sure then that your calculations are based on, your further calculations are based on the limiting reactant. So we've done that now, that's part A. Part B is the percentage yield of nitrogen monoxide. So using this information here from the limiting reactant, now I'm going to look at my mole ratio of oxygen to nitrogen monoxide. and it's 5 to 4. So my theoretical yield of nitrogen monoxide would be 4/5 of that. I'm talking moles here. Do you know why it's 4/5? Okay, the one we're finding divided by the one we have. It also makes sense when I look at this. If that 4 is smaller than 5, the number that I want to end up with, the moles that I'm going to produce, needs to be a number that's smaller than that. So I can be looking and thinking while I'm doing these calculations to make sure that what I'm doing makes sense. And then I get 0.15, which is 0 moles. Now I know the moles. I wanted to find the mass. So remember, when I rearrange that relationship up there, the sample mass is equal to the moles times the molar mass. So my mass of nitrogen monoxide will be 0.150 multiplied by the molar mass of nitrogen monoxide, which gives me, according to the book, 4.65 grams. But if we look back to the original part of the question where it told us that we only produced 2.75 grams, this was my actual yield. So, and this is my theoretical yield. So my percent yield is my actual divided by the theoretical multiplied by 100. So 2.75 divided by 4.65 multiplied by 100 gives me 59.1%. Okay, now, and this question, the way it's been structured, leads you through. It tells you to find the limiting reactant. But in exams, it probably won't. It's going to expect you to see that you're given the quantities for the two reactants and expect you to know that you're going to need to find the limiting reactant first before you can go on to find the percent yield. Okay, does that make sense? Does anybody have any questions about that? Okay, let's go on and work on some questions then.